Just main points only I would like to discuss now. Just for those points only, please concentrate. See, first of all, dominate on these topics, just like a aquifer, aquiclude, aquitod, aquifuge. If you know these four definitions, just you are supposed to get 2 marks. Then next, types of aquifers: confined aquifer, unconfined aquifer. Then aquifer parameters like porosity, specific field, and permeability. Anyhow, permeability and porosity are already studied in soil mechanics. Same thing repeated in here also. But I think is specific field. This I think you may have heard new term in this subject. Then coefficient of transmissibility or transmissibility T equal to coefficient of permeability multiplied by thickness of the aquifer. T equal to K into B, very very important formula in our examination point of also calculations and 2 marks questions also. Anyhow, types of wells, Darcy's law. Then radial flow to wells, both confined and unconfined aquifers, is supposed to give much importance to our examination point of view. Of course, this may not discuss much. Only thing is there is a knowledge point of view. So we discuss only examination questions. It's only for knowledge only. This may not give much important for the examination point of view. So aquifer, this is our subject, right? So aquifer, aquiclude, aquifuge, aquitod. So you know very well about in engineering geology also. Same thing, same definition. No need to change the definition also. Once you prepare the definition for that subject, you can incorporate for this subject also. Confined and confined aquifers. Once again, this also aquifer parameters. So porosity, so volume of water total volume, right? N equal to porosity. Specific yield also explained again. See, it is the ratio of the volume of water that drains from the groundwater storage due to the attraction of gravity to the total volume of the saturated aquifer. Please note down the definition. This is important for the 2 marks question. Please write down the definition, total definition. So a specific yield, commonly denoted by SY, equal to ratio of volume of water that drains from the groundwater storage. That drains from the groundwater storage, right, due to the gravity by to the total volume of the saturated aquifer. So SY equal to Vy by V. Vy means volume of water drained from the groundwater. That's you remember like this. So specific yield. Then specific retention is just for a drain out and just balance. It is a ratio of the volume of water that cannot be drained out to the total level of saturated aquifer. That's called specific retention. Retention, the name itself indicates retention. And coefficient of permeability, it's a very, very important term in this also. Soil mechanics, engineering geology, and this subject also for the problems. Some problems they may ask, find out the coefficient of permeability, calculate the coefficient of permeability like this. Units of coefficient of permeability is very important for our competitive examinations. So see, once again, I request you to write down the definition also. The coefficient of permeability is equal to the discharge meter cube per second per unit area of soil mass under unit hydraulic gradient. Right? Of course, you know the units also, say centimeter per second or meter per second or meter per day. Please write the definition. So the coefficient of permeability may also called as hydraulic conductivity. Next. So permeability factors, permeability factors affecting permeability. You know, where Darcy's law V is equal to K into I. Assumptions of Darcy's law. This one is also transmissibility, based on definition also. So it is a discharge rate at which water is transmitted through a unit width of an aquifer under a unit hydraulic gradient. So transmissibility T equal to K into B. Specific storage, volume of water released from the storage per unit volume of aquifer. Just no need to write all this thing. At least units please write down. Transmissibility meter cube per day per meter, or straight away meter square per second. But correct unit is meter cube per day per meter, like this. Because of its K into B, coefficient of permeability, coefficient of permeability also discharge per unit weight, like this, meter per second or meter cube per second, like this. Next. The transmissivity of an aquifer is also known as transmissibility. It is a product of the hydraulic conductivity K and the thickness of the aquifer. Please write down once again, because I mean why I am repeating the many times is it's very, very important for 2 marks questions. T equal to K into B. That's all. If you write this equation, you can get 2 marks. Here also observe Q is equal to area into velocity. You know, area means unit width. That's why B into 1. Into velocity means K into I. So K, I means hydraulic gradient dH by dt. Head difference due to the total length dH by dl. So Q is equal to K into B, like this. T is equal to K into B is a transmissivity. Just read the problem. No need to take the problem, I think. It is regarding specific yield problem. When 3.68 million meter cube of water was pumped out from an unconfined aquifer of 6.2 square kilometers aerial extent. See, once please understand the problem practically. So this much of water is pumped from an unconfined aquifer. So you know the groundwater is consists of aquifers. Aquifers again confined and unconfined. So this area is about 6.2 square kilometers. The water table was observed to go down by 2.6 meters. What is the specific yield of the aquifer? During a monsoon season, if the water table of the same aquifer goes up by 10.8 meters, what is the volume of recharge? See, please read the problem, understand the problem. See the solution. So water release from the aquifer. So this much. So go to specific yield definition and substitute this. How 6.2 in 10 power 6 to 6.2 square kilometers into convert into meter square into 10 power 6 into how much depth was the drawdown 2.6 into SY. So SY, what is the definition of SY? Specific yield equal to volume of water released or pumping by total volume. So total volume into SY. So water pumped out how much? 3.68 into 10 power 6 cubic meter. It's already given. So equating these two, so you can get S5 specific yield. Specific yield always in percentage because of its ratio of volumes. Volume of water released by total volume is volumes. So maybe percentage. Then volume of recharge again. Recharge is 10.8 minutes recharge unit. So same 6.2 10 power 6 into 10 power 8 recharge into S5. So volume of recharge. This one like that. This is supposed to calculate. This also please read the problem and take the solution. The water table levels in two observation wells 350 meters apart are levels are mentioned like this. Hydraulic conductivity and porosity of the aquifer is 12.5 meter per day and 15%. What is the actual velocity of the flow in the aquifer? Please take it in a solution only. Firstly, V equal to K into I. So V equal to hydraulic conductivity 12.5 meter per day, right? dH by dt means hydraulic difference, head difference. Into the 206.25 minus 210.5, it's elevation difference by total length 350. So you can get 0.1 like this. So what is the porosity? So actual velocity equal to V by N. So 0.15 it's a by 0.15 porosity, you can get the actual velocity of the aquifer. Steady radial flow into a well. Draw this diagram. This is examination point of view. Steady radial flow to a well in an unconfined aquifer. Just okay, or otherwise I will explain you once again. Main well. This is the main well, right? Main well discharge Q of radius R. Two observational wells are situated at a distance of R1 or R2 from the main well. So the drawdown of the two observational wells are S1 and S2. H is the thickness of the total aquifer. This is a cone of diffraction because of during drawdown, right? The curve is like this. This is the point where the drawdown is zero. What's called as radius of increase capital R. Just first, please draw the diagram and indicate the points. One main well, two observation wells, so situated at distance of R1 and R2 from the main well. H1 and H2 are the height of the water table. S1 and S2 are the drawdowns, right? SW is the drawdown of the main well. HW is the height of the water, the main well. So at an distance R from the main well, like this, the drawdown is like this. So H is decreaser or increaser like this. So the small h, it's capital H. This is a water table, original water table. Now, step by step, please. In a steady radial flow, as shown in figure, already shown, the depth of flow at any radial distance R from the well is H, like this. See, I will show you. Right, the depth at the distance of R is small h. The depth of flow at any radial distance R from the well is small h, and the area of flow at this section means 2 pi r h, because the circumference, you know that 2 pi r into h. According to Darcy's law, the velocity of flow is given by V equal to K into I. I is equal to hydraulic gradient. Then Q is equal to area into velocity. That's area means 2 pi r into h. Velocity K into I, K into dH by dr. Second, rearranging the terms. So take it as left side, h into dh equal to q by 2 into pi into k. dr by r. Just these two lines are very, very important to find the derivation. It's right now. Integrating the above between the limits small h to capital H, small r to capital R. Like this. So h dh into q by k into dr by r between the limits r1 to r to h1 to h2. So finally, you are supposed to get this formula. This formula is very, very important. Directly, you can substitute the directly into the problems. Q is equal to pi into k, h1 square minus h2 square by ln natural log, ln r2 by r1. If you remove the natural log, 2.303 log 10, like this. So once h1 to h2 or h2 to capital H, or this r1 to r2 or small r to capital R. So where H1 and H2 are the water levels in the two observation wells located at the radial distances R1 and R2 respectively from the main well. The radius at which the cone of depression just commences is known as the radius of fill phase. That's because where the drawdown is 0. This also please write down. This formula also 9.34 and 9.35 is very important. You can substitute the directly as per the problem given like this. It's R to R. Small r to capital R ఇక్కడ లోయర్ లిమిట్ అప్పర్ లిమిట్ తీసుకుంటే ఈ ఫార్మ్ వస్తుంది. అదే హెచ్ టు క్యాపిటల్ హెచ్ తీసుకున్నట్టు ఈ ఫార్మ్. దట్స్ ఆల్. This is one of the important derivation. Just problem చూడండి ఒక ప్రాబ్లం ప్రాక్టీస్. An unconfined aquifer has a thickness of 30 meters, a fully penetrating 20 centimeter diameter well, అంటే diameter is given, you can convert it into radius d by 2. Well, in this aquifer is pumped at a rate of 35 liters per second, dead discharge. The drawdown measured in two observation wells located at a distance of 10 meters and 100 meters, that's R1 and R2 from the main well are 7.5 meters and 0.5 meters respectively. Determine the average hydraulic conductivity of the aquifer. At what distance from the well the drawdown is insignificant. Please take solution. Don't need to write the problem. Just straight away, please Q is equal to pi into k, h1 square minus h2 square by ln r1 by r2. So as it is k equal to q. So you are supposed to find out the hydraulic conductivity. Take it outside hydraulic conductivity k equal to q into ln r1 by r2 by pi into h1 square minus h2 square. So q 35 liters per second converted into meter cube per second. Everything is a meter or meter cube per second like this. Substitute directly. ఇక్కడ h1 h2 కావాలంటే ఏం చేయాలా? h1 ఈక్వల్ టు టోటల్ h మైనస్ డ్రాడౌన్. h2 అంటే కూడా అంతే, టోటల్ h మైనస్ డ్రాడౌన్ అట్ సెకండ్ పాయింట్. Straight away you can get. So straight away substitute it, get the hydraulic conductivity like this. So if it is a meter per second, convert it into meter per day also, like this. Then insignificant means radius of influence. You are supposed to get radius of influence like this. Same formula, only R to R. ln R by n R by, you can supposed to get calculate R. Let's take this formula also. So R equal to 120.7 meters, you are supposed to get like this. So if you remember that formula, that you can apply it for anything, sometimes hydraulic conductivity, sometimes discharge, like this. Now, confined aquifer. This also please, this is also simple derivation. Same thing, only change in unconfined and confined means the thickness. Confined between the two layers. Confined means this is confined between the two layers. It's only B is supposed to be coming to picture in the case of confined aquifer. Same, main well. Sir, చెప్పండి సార్. వెబినార్ అటెండ్ అవ్వాలా? సరే సరే చూస్తున్నానండి. ఎక్కడికి వెళ్ళాలి సార్? అదే వెబినారే కదా. అదే అదే ఓకే పెట్టేసేయండి. అదే 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 సరే సరే సార్. థర్డ్ ఇయర్ చెప్తాను, మున్సాం కూడా అట్టున్నామని చెప్తారు. అదే యాక్చువల్లీ మనం మున్సాం పెట్టాం, ఇదేం చెప్పాలి థర్డ్ ఇయర్కి. సో మున్సాం ట్రైనింగ్ ఇస్తున్నాం కాబట్టి నేను మున్సాం కూడా వినమని చెప్తాను. అది కోడ్ బీటా అనేది ఓన్లీ సిఆర్టీ సార్, రిజిస్టర్ అయిపోయినారు థర్డ్ ఇయర్ ఇప్పుడే. కోడ్ బీటా అనేది ఓన్లీ సిఆర్టీ వాళ్ళకి. అది అది ఇన్ఫోసిస్, అది వేరు. అది 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 ఈవెంట్, అది ఈవెంట్. అవును. బట్ మా మెయిల్ అయితే మాత్రం ఓన్లీ థర్డ్ ఇయర్, ఓన్లీ సెకండ్ థర్డ్ ఇయర్ సిఆర్టీ స్టూడెంట్స్ అని వచ్చింది సార్ మెయిల్లో. అంటే మనం సిఆర్టీ కాదు కదా మరి, అంటే అన్ని అందరూ రిజిస్టర్ చేసుకోవాలి. సరేలేండి, అంటే మరి రకరకాలుగా వస్తున్నాయి, వాళ్ళకి కన్ఫ్యూషన్. మెయిల్ క్లియర్గా ఉంది నాకు, మన ప్రిన్సిపల్ ఇచ్చిన మెయిల్ సెకండ్ థర్డ్ ఇయర్ సిఆర్టీ స్టూడెంట్స్. సరేలేండి, ఎందుకు వచ్చింది కూడా మొత్తం అందరినీ పెట్టేద్దాం. సరే సరే సార్. So main well, two observation wells situated R1 and R2 from the main well. These are drawdowns. This is thickness of aquifer. There is just this derivation of two lines. Dots is the way you K into I. Straight away you are supposed to get this one 2 pi t into S2 minus S from the island R1 to R2. Please note down this formula directly. like this, you are supposed to practice a number of problems in both confined and occupied also. Derivation and problem. Definitions. See, once again, groundwater law, definitions, derivations, then two direct formulas. That's it. 1 minute. Oh, sir. Sir. Okay. Okay. Hmm. 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 Okay. 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 Hmm. 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 సరే సార్ సరే సార్ అది నా మెయిల్ పంపిస్తాను అయితే మీకు నాకు వాట్సాప్లో పెట్టేయగలరా మెయిల్కి వస్తుంది సార్ వాట్సాప్లో వస్తుంది సార్ డైరెక్ట్ క్లిక్ చేస్తే వచ్చేస్తుందా సరే ఓకే ఓకే సరే 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 సార్ ఇది అటెండ్ అవ్వడానికి మీరు అన్నట్టు అందరూ ఫస్ట్ ఇయర్ నుంచి ఫైనల్ ఇయర్ వరకు సో అన్ని గ్రూపులో పెట్టించేస్తాను ఓకే రిజిస్ట్రేషన్ కూడా థర్డ్ ఇయర్ స్టూడెంట్స్ ప్లస్ ఫ్యాకల్టీ ఓకే 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 రిజిస్టర్ చేసుకోవాలి ఓకే 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 సరే సార్ సరే సార్ So for that, okay, we shall stop here. Yeah, Arun.